Hey everyone, thank you for joining us to our session in RSA conference, Get Rich or Get Hunted Trying, Uncovering Large-Scale Fraud Operations. My name is Tal Darson, and I'm managing the Cybersecurity Research Lab group Introsphere Labs, IBM Security. Here with me today is Dana Peleg. She's heading our web research group in Introsphere Labs. And today, we're gonna show you a few examples of interesting attacks that our lab covered. So I'll hand off to Dana to begin with the conversation, and I'll meet you guys later during it.
Thank you, Tal. So thank you everyone for joining us. A short introduction to what we're going to see today. So first of all, we're going to talk about the recent changes in the digital world that we're seeing. Later on, we're going to touch the COVID pandemic and how it affected the threat landscape trends. And then we will present attack overviews that are very interesting that were analyzed and dissected in our research lab. And of course, countermeasures, how to address these threats. So I'll start with the digital transformation. This is something that is going on for a while now, and it keeps being enhanced and accelerated. And of course, with the COVID-19 pandemic, people are working from home, and this is increasing the amount of users logging in to different platforms and organizations as well. So, of course, this actually leads to new targets. Many new victims, potential victims are out there, and they can be targeted and lured into unique attacks that we're going to share with you. The unmanaged corporate devices being used, the bring your own device model is being used in this very recent pandemic. So people are actually using their private devices to log into organizational platforms and whatnot. And this is very dangerous since they do not have the organization's policy and security measures such as antiviruses and firewall and all of that. And we're also seeing the attacks magnitude is on the rise, again, since we have a lot of new targets, not just the end users that are logging in, but also a lot of companies and organizations that are now having new online platforms to serve their users or customers during the quarantine and giving them alternative ways to communicate. Also, we're seeing some changes in the attacks tactic, techniques, and procedures, and this is something that we're going to share with you, and it's very exciting. So, of course, we see a lot of things in our lab. We analyze threats from the web and mobile channels, also everything that is social engineering. These are things that we are looking into. And today we're going to focus on main very large-scale attacks in the phishing field and in the mobile emulator field. So I'm going to start with the phishing field, and it's very interesting. So phishing is a very old threat. We thought it would go away. It's not going anywhere. It keeps improving and getting more and more sophisticated. So we're seeing growth in top-level domains. This will provide the expedite of the domain registration and provide a lot of ways to basically lure more victims into falling for the attacks. Another thing that we're seeing is using SSL certificates. So once, way back, you used to tell your relatives, hey, look for the padlock in the URL address search bar, and this will indicate that your connection is secured. This is no longer the case. A lot of phishing attacks are using SSL certificate as well. And another thing that is we're very familiar with, and it keeps rising, is using session randomization folders. So in this way, the actors are creating unique URLs. This can go up to thousands of unique URLs for just one attack. So for each end user browsing to the site, you can see a new folder that is being generated and creating a new unique URL. And of course, man-in-the-middle attacks that we're going to drill down into. So first of all, COVID-19, we've seen some new delivery methods. In this case, some phishing and malware delivery emails. So we're seeing some fake White House instructions. They're sent from the president. Of course, this is not the case. It's completely fake. They're trying to use scared people that are very worried for their financial status and, of course, their health. And they're talking about groundbreaking steps to slow the spread of the virus, also some IRS tax adjustments. Of course, this is completely fake and delivers the attacks. Moving forward, I'm going to discuss some really cool anti-research technique we've seen in our lab. So a lot of actors are trying to bypass security measures and vendors. And so in this case, for example, the actor is trying to take a look at the geolocation of the end user trying to browse to the attack. So for example, this attack targeted a UK brand. And as you can see below, the actor is trying to see where is the user browsing from. And if the IP is located out of the UK, the victim or potential victim will actually reach to a 404 not found page, meaning he will be blocked and will not be able to browse to the phishing site. And this way, the actor is eliminating unrelevant or unreal credentials from reaching to his CNC command line. And moving forward to additional ways that the actors are using. So for example, in the session protection part, there is a snippet that actually is indicating where did the end user reach to the phishing pages. So if I'm just a regular victim, I will go through the main flow of the attack. For example, I will start with the login page, enter my credentials, be redirected or moving forward to the second page of the attack, and so on. So in many times, security vendors can get the access directly to different stages or different pages of the attack. And this is something that is, of course, not a regular victim will do. So the actor is blocking them out of reaching these pages and just present them the Google page so they won't be able to analyze and take down his site. And another thing that he can detect is proxy usage. For example, if we talked about geolocation detection, then in this case, a lot of security vendors will hide their IP address, whether it's to protect their own identity or to bypass the geolocation protection. So the actor is looking for, are you using a proxy-related IP address using a third-party service? And in case you are, you will also be blocked from reaching to the phishing site. So these are just a few parts that you're seeing. And of course, the actor has a blocked IP list, a ranges list. And for each and every visitor that he will get to his phishing site, he will compare the IP address to his blacklisted IPs. And in case these are not in the blacklist, then these addresses will log in to the accepted visitors list. And he will be able to tell these are victims that are relevant to him. In case these visitors are in the blacklist IP address, then they will be logged into the denied visitor list and of course will not be able to access the phishing page. So they will also be redirected to Google. And in this way, he is blocking, for example, the ranges of security companies and research entities, so he can know that in advance. So these are just a few of the methods that we've seen. And what I'm going to show you now is a very, very cool man-in-the-middle reverse proxy phishing attack. So if you are familiar with regular phishing attacks, you probably know, and if you don't, I'm going to share that with you, that once the user enters his credentials to a phishing site, he's actually being redirected once the attack is over. He's being redirected to the legitimate site of the targeted brand. So because he is not entering his credentials to a real site, he will not be able to reach his account, of course. So the credentials will be forwarded to the actor and that will be all. But in this really cool technique, this is not the case. What actually happens is the actor is using a reverse proxy server. And in this way, he can reflect to the end user, to the victim, the legitimate site, and doing that and showing the end user that he is on on his legitimate account while actually being on a phishing site. So he will not be able to see that. And this is being done for hijacking the entire session of the victim. So I'm going to show you what we were able to reconstruct in our lab, a really cool technique using EvilJinx server. But EvilJinx is just one way to do it. There are a lot of other projects out there. So in this case, we're actually in the role of the actor. We're actually loading our project, which is the EvilJinx. And we have purchased a cloud server and domain that will host this attack. So in this case, we're enabling the phishing attack that will target, in this case, the very unfamiliar platform named Instagram. So what you can see here is how we get the full URL of the attack using the domain that we've purchased. This is the full URL. And now let's take a look on the end user, on the victim's end. So he's browsing to the phishing site. What he sees is the fake site, the login page. You can see his credentials. And what I want to show you is, keep in mind this password, the legitimate one, starts with the digit 1. This is important for what I'm going to show you later on. So the end user just logged in and he's in his account. You can see the feed. You can see the profile of the victim. So this is very unique because, as you can see in the address bar, this victim is actually on a phishing site, but he can see his legitimate account. So this is how this server reflects the legitimate account. And in green here below, you can see the credentials that the server has captured. So you can see an email address and you can see the password. Again, it starts with the digit 1. And now with using the session command, we can see some more information and the remote IP that is being used. And by choosing the exact ID of the session, we can see some drill down information and session tokens that will actually allow the actor to conduct a full session hijacking. So in this case, the session ID token is being used, and you can see that we're using some kind of a cookie editor to conduct that. So we're actually trying to connect to the legitimate end user or the victim's session that is currently live. But what you can see on the address bar is that we're on the legitimate Instagram site. Okay, so we are now on the legitimate site trying to use the stolen credentials and stolen cookies and actually hijack the end user's entire session. So refreshing the legitimate site using these stolen tokens, and we're going to be directly in the user's account. You can see this is the victim's account. You can see his feed, and you can see that we're on the legitimate site. So we are now in the online session that is happening, but we've entered that without the stolen credentials of user password, right? So I'm going to show you why we need them for. So in this case, what we're able to do is actually change the password to complete the full ATO of our attack. So we will use the old password that we just captured, and we will create a new one. So this will allow us to be able to log in to this account on the legitimate site, and will actually block this user from doing that on his end. So as you can see, the password has changed. You can see below the alert, and logging on from this legitimate account. And in this case, we are the actor. So we logged on after changing the password. Now we're going to use our password that we've created and the victim is not aware of. And you can see it starts with the digit 2, right? The first one started with the digit 1. And there you have it. We changed the password. We're able to log in. And the user is actually blocked out of his account. And this is just a personal user. Imagine what can be done to business accounts. How can this be monetized? And so this is something that is very, very interesting and unique. And we were very happy to analyze and investigate here. So what we see also is different types of kits that are using this method. So in another case, we've seen, for example, a global financial institute that was being targeted all around the world. So in this case, even the delivery method was unique because the actor used a unique token for each and every email that he sent, of course, automatically. And this, if you were not using that URL, the unique URL, you were not able to browse to the phishing site. So it's not only that, is also the the phishing attack, the phishing URL is also using non-ASCII characters to resemble as much as possible to the legitimate site with special characters. And once the user was on the phishing site, he was actually trying to change his OTP settings. So in the email that the fraudster sent, he was asking victims to change or update or make sure their mobile number is updated in the account for 2FA purposes. So in this case, what the victim was doing is trying to update his number. But since the actor was hijacking his session, he was able to enter his own device number, his own mobile number, and this way bypassing 2FA methods. And now he has both his credentials, user password, and the mobile device is his own. So he can log into that account, get the OTP password to his device, and complete the full ATO. So this is just one way to do it. It's very interesting. There are a lot of methods, and I'm going to hand off to Tal to talk about the large-scale mobile emulator fraud.
Thank you, Dana, for the phishing session. And now we're going to discuss another interesting massive account takeover that we have discovered recent year, which was around Mobile Emulators Farm. So what is Mobile Emulator? Mobile Emulator is basically a software that's installed on desktop devices in order to mimic mobile devices. Of course, you can pick different devices with different features and how you want them to act like. And what fraudsters did is they actually utilized this into a massive farm of account takeovers. So think of these attacks like Dana explained, or phishing attacks, for example. So due to COVID situation, there were massive attacks of phishing that we've seen. And the fact that there are a lot of credentials being stolen had the fraudsters to act smartly and do a mass operation, and where they're using a massive account takeover to do this verification, and then on transactions, of course, from the accounts they took over of. So think of just an example of phishing attacks. As you can see in the slide, there are plenty other opportunities for threat actors to put their hands on credentials, whether it's from malware attacks that also grew in the recent year due to the COVID pandemic, and whether it's from a lot of data leaks of people that lost their credentials in different leaks and they end up on the dark net. So what the fraudsters group did is they took all of these stolen credentials alongside with other indicators from these compromised sessions, so they can be able to spoof and look like they're logging from their own device, from the original victim's device. They actually store them on a command and control server, and then they started the mass operation when they do several actions. So what I'm going to do in the following slides, I'm going to walk you through what of these farms that we have actually detected and how they operated. So in the first stage, what we have discovered is from two different actors, actually how they do device fingerprint spoofing. So as I said, it's not enough today just to steal your password and username. Of course, there are a lot of other mechanisms such as, multi-factor authentications that prevent you from logging in once they detecting you're not coming from your own device. So actors, of course, studied it and they know that. And therefore, in one of the operations that we have uncovered, they use this following software, as you can see in the slide, in order to conduct the actual change of features in the device, it will look like it's from the victim device, such as the device model, device country, operator, etc. In another case we uncovered, the actors were actually were developing their own code, their own software within the emulator to conduct this perfect spoofing. So there are a lot of features here that you can see in this code snippet that we have taken from one of the applications that we have gathered, which is of course also CPU, ID, manufacturer model, etc. So in order to conduct this perfect spoofing, you must be able to change the device attributes and features. So this is just one example from our internal ELK stack when one emulator created about 8,000, more than 8,000 cases of compromised sessions. So you can see the different models of Android actually devices that were uncovered in this case. And it's just not that. Yeah, you can see a lot of other specs here from device build fingerprint to device build board, product build model, etc. So it's just give you the sense of idea of how from just one emulator attack, the amount of sessions that were actually compromised in this attack. The other thing that these actors were doing is they, of course, want to change the network connection of the sessions the original victims are coming from. So there were a lot of options of how they did this. So from actually implementing a SOX proxy application that's tunneling the original victim's network into the actual fraudster's server. So it could be seen like the fraudster has the IP address of the original user. And this is like for the advanced cases, of course. In other cases, the fraudsters could just implement their own VPN connection from the device, whether if it's from open source VPN applications to just known accounts like the ones you see, and the fraudsters can just pick one from the Play Store, from the Android Play Store, and just install them on their server. So far, the fraudsters are making all of this automation in doing this device spoofing, fingerprinting spoofing, and geolocation. What we have seen more is in that same application that we have uncovered, the actors also created hooking on the targeted applications that they were targeting, and of course, in order to conduct their account takeover phase. And they're actually listening to the entire network stream that got out of these sessions. So they can understand and be able to debug some of these sessions, and also to understand if something happened in these sessions that need to be modified in order to conduct a successful ATO. So they also have this phase when they're just looking at the network traffic coming and getting out from their servers. So now you're asking yourself, okay, how all of this orchestration is working. So all of these things are all tied in scripts that were crafted for the mission of conducting this perfect account takeover in a mass scale. So just think of all the credentials that were taken, whether it's from phishing attacks, malware attacks, darknet, compromised credentials over the darknet. And they were all got into this automation where scripts are just going into the original application of the original provider of the victims and just typing the credentials, login credentials, password, the username. But now you're asking yourself, okay, so what about the second factor authentication or any other source of one-time password that these original providers are actually using? So there are a lot of ways that the actors can do. So one of the ways is just sending an automated smishing attack to the victim once they have their of course, compromised credentials. With these credentials, sometimes they have other data, such as the victim's phone number, of course. So they can send him an SMS with some kind of a social engineering, asking him to type the password or the one-time password that he just got on his device for some kind of a good reason. And guess what? A lot of people are falling into that and just giving their number, giving the OTP number into that smishing attack. By that, the OTP number is being set to the remote server, and from that part, the account takeover completed at this point. There are other ways. Actors can install malware that knows how to hijack the one-time password. This is, of course, a classic case, which is like, fraudsters have been doing for a long time. But in this part of automation, this could also be automated as part of the victims were infected by malware. And last part are also could be with robotic phishing calls, where the actual victim getting a call from some kind of call center that identifies to be the original provider, and some kind of a robotic call asking from the user to type the one-time password he just got to his device in order to, for some good reason, to unlock his account, to continue some operations, and, some social engineering scam. So a lot of people are falling into that. By that, they're ensuring that the second factor authentication will be bypassed later on, which brings to transfer of funds. But not everything is bad as may seem. So far we showed you these, let's put it this way, dangerous attacks, both on, automation of account takeover and both on the phishing world, where attacks became sophisticated in 2020 and 2021, and we believe they're going to get more within the years. So in order to tackle the mass attacks that we're seeing these days, we need to use AI. So what's an AI? Okay, of course, artificial intelligence, but how it works like. So in order to briefly explain the method, so think of that you want to learn your machine to recognize something. For example, in this case, apples. So yeah, apples, they're, in this example, they're red, they're kind of rounded. They have a green leaf. And we learned the model, the machine. Okay, so look, these are apples, and these look like apples, okay? These are their features, and these are their color. And then we provided with the machine with an apple, and we asked the machine, what's that? And then the machine responding with, yeah, that's an apple, because now I studied its features, I know how it's being constructed, and now I know how to detect it. So the same we do for cybersecurity. So for example, what we did and what organizations are doing these days, actually using AI to combat threats. So for phishing, for example, so you can see in the upper images, you can see on the left side, this is a compromised website that was uploaded a phishing site into it of a massive retail provider. On the right side, you can see just the original compromised domain. So you can understand that the look and feel of these two websites are completely different, although they're hosted on the same landing page. So what does it mean? It means that they have many features in their internals of their HTML source code, JavaScript code, and a lot of other CSS code, the style and whatnot of these two both websites on the same domain that they are being constructed from. So think of that. I mean, that's one idea of how machine can differentiate between the two. And on the bottom line, you can see, for example, the organization we're presenting, which is going to want to give you an example of the logo detection. So how logo detection helping with combating phishing? So there are a lot of websites which, let's put it this way, naive scanners won't help you these days. They're doing the maximum efforts, fraud actors doing the maximum efforts to make sure their code is pretty much minimized without any sense of understanding and relations to the targeted organization. So what you've left is the best phishing attack, which must be constructed from the original targeted logo, of course, and look and feel of the targeted brand. So one of the things that artificial intelligence could be used to as one of the features of the entire machine learning process is using a logo-based image detection. So these are just a quick example of how you can leverage AI to combat phishing. So with that said, what you need to do, okay? What you need to do in the upcoming weeks. So first of all, you must look for your organization for blind spots, okay? You must understand whether you have the best security processes in place. You must understand, do you have the right security processes and tools in place in order to combat attacks like we've seen today and more? What else you need to do in the upcoming weeks after is you need to find and think of the best strategy after you detected these gaps, these blind spots, and whether you have the right tools in place. And you need to think of how and what tools do I use that give me the best and less friction, you know, of course, by the lowest cost. And this is the things that are pretty much obvious to every organization these days. And later on, what you'll have to do is, of course, that if you understand that what you need to do in your organization is facing tremendous attacks from versatile, let's put it this way, versatile attacks, whether it's from, you know, web, malware, phishing, and whatnot, you must understand if you're experiencing a mass scale of attacks, and therefore you need to think of an AI-based solutions. But I must add that AI solutions are not enough by their own. Of course, that AI will always be accommodated with some lower percentage, of course, in, you know, the best tools of false positives. So in order to make sure you have the best security measures in place, you also must know that you must choose the right tool to be integrated with other heuristics and rules in place that will come in conjunction with an AI solution. And of course, you must continue to assess the threat landscape that your organization is facing. So I hope you have learned a lot of new stuff today, and you'll make use of the advice that we gave you. And take care. Thank you.